Next example for you. Here we have a system of linear equations, 1, 2, 3, and 4 equations with 3 variables. So how do we solve this? First, we're going to write down the augmented matrix, which is 1, -1, 2, and 4. Basically 1 times x1, so 1, -1x2, -1, 2x3, 2, and the constant term is 4. Then you move on to the second equation. The coefficient of x1 is 1. There is no x2, so the coefficient is 0. 1x3, 1, and then you have a constant term, 6. Then you move on to the third equation, 2x1, 2, minus 3x2, minus 3, 5x3, 5, and the constant term, 4. And on the very last equation, you have 3x1, so 3, 2x2, 2, -x3, -1, and the constant term is 1. But what is our goal? Our goal is to make this augmented matrix into this form as much as we can. What are we going to do? We're going to apply elementary row operations, interchanging 2 rows, multiplying a row by a non-zero constant, and add multiple of a row to another row. Order is not important at all. So what you can do, you have 1 as the leading coefficient, which is basically the same as the format that you have. So everything below 1 must become 0. What you can do, you can multiply the first row by -1 and add it to the second row. Multiply the first row by -1 and add it to the second row. -1 plus 1, 0. 1 plus 0, 1. -2 plus 1, -2, and -4 plus 6, 2. Then you can move on and jump into the third row because you're going to make this guy equal to 0. What you can do, you can basically multiply the first row by -2 and add it to the third row. So -2 times the first row added to the third row makes this guy equal to 0. So let's see. 1 times -2 plus 2, 0. -1 times -2, which is going to be 2, minus 3 gives you -1. And then you can continue the algebra behind it and you get your new third row. In the next step, we see that we have the leading coefficient in the first row 1 and everything below 1 is equal to 0, which is basically the format that we're expecting. Now you're going to jump into the second row and check to see if you have 1 as well or not. So as you can see here, you have 1. Your goal is to make elements below and above 1 equal to 0 in the reduced form, or you can just leave it in echelon form. So here you have 1. If you add the second row and the third row, this guy becomes 0. So R2 plus R3 replace for R3. You're going to have a new third row. 0 plus 0 is 0. 1 plus -1 is 0. -1 plus 1 becomes 0. 2 plus -3 becomes -2. Very good. Now you can easily take this guy and write a system of linear equations. You don't have to go to the next stop. You can just stop at this point. Sometimes the students say that, okay, we're going to add R2 and R1 and make this guy equal to 0. Why not? You can go ahead and do that. But I'm looking at this third row here. This third row helps me to stop at this point. Why is that? Because the third row says, hey, 0 times x1 plus 0 times x2 plus 0 times x3 must be -2. It means that it says, hey, I have 0 equals to -2, which is basically a contradiction. What's the meaning of contradiction for the system? It means that this system has no solution. The system is inconsistent.